everybody. In Algebra 2 Trig, this is a video notes for second week. We are talking about solving polynomials. So, a couple of big ideas from this. When you're solving polynomials, if there are different powers of the variable, so looking at this example from number 1 in the notes, x cubed, x squared, right there, different powers of the variable. You need to set it equal to 0. That's step 1. Some other big ideas before I get going in solving this. The degree of the polynomial, highest power of any of the variables, is the degree 3. That means there are going to be 3 zeros. It could be 3 real zeros, it could be 1 real zero and a couple of imaginary zeros, but no matter what, it's degree 3, 3 answers, real or imaginary. Okay, so let's get solving. We need to set it equal to 0. So I'm going to subtract 3x squared from both sides. That gets us to be set equal to 0. That's what we want. Combine some like terms. We got 4x cubed. This becomes minus 10x squared. Once you have it set equal to 0, do some factoring. So looking at our two terms here, we have, looking at the 4 and the negative 10, we can factor out a 2. With the x's, we can factor out an x squared. Getting used to this pen, sorry. X squared. What is left over? We have a 2x from our first term. We have a minus. We have a 5 from our second term. Equals 0. Okay. Once you have it in factored form, set your factors equal to 0. 2 equals 0. No, it doesn't. So no answers come from that. No big deal. X squared is really x times x. So I'm going to break that apart. X equals 0. Stupid pen. X equals 0. The other factor of x equals 0. And then our parenthesis. 2x minus 5. That factor equals 0. So now, these two answers, they are the same. So what we do is we say x equals 0. And then we put it as with multiplicity 2. It's the same number, but we got 2 of those. If we had 3 factors of x, then we put 0, x equals 0 with multiplicity 3. Then we solve this one, add the 5, divide by 2, x equals 5/2. So here's one answer. 0 happens twice. So we got 1, 2, 3 answers. It was a degree 3. Yay for us. That's how we do that one. Okay, number 4 from your notes. This one looks a little bit more complicated, but here's the deal again. We have different powers of the variable. We got x to the 4th. We got x squared. So now, this one is actually quadratic in nature. X to the 4th. So what we're going to do is basically factor it. X to the 4th is really x squared times x squared. So basically, I'm doing FOIL in reverse. Our last two numbers have to multiply to be negative 42. At the same time, when we do the outside and inside part of FOIL, we got to get our middle term of positive 1x squared. So I like plus 7. Come on, pen. Plus 7 and... Here we go, minus 6 equals 0. All right, it's in factored form. So I'm going to set my two factors equal to 0. All right, I'm going to start with the second one because this one's pretty much more straightforward. I'm going to add 6 to both sides. Then I'm going to take the square root of both sides to get rid of that square. Those are terrible square roots. Whenever you take the square root of both sides of an equation, you're going to get two answers, positive and negative, square root of 6. Okay, over here, subtract 7 from both sides. X squared equals a negative 7. When we take the square root of both sides, square root of negative 7 is not a real number. But again, we can use imaginary numbers. So, a couple of things. We took the square root of both sides. So we're going to get our two answers of positive and negative. There we go. Positive, negative. Square root of negative 7 is I times square root of 7. So it was a degree 4. There should be 4 answers. Positive and negative root 6 is 2 answers. Positive and negative I root 7 is 2 imaginary answers, but that's a total of 4. So there's our 4 answers for degree 4. There's going to be another video on question number 10, just because it was factoring by grouping, and several of my students made some mistakes with the factoring by grouping, so I want to go over that one. But this is the idea of some of the big ideas for this week's of work. I hope everything's going well for everybody. Take care.